In this video tutorial, I am going to discuss about this important exam question, that is why α1-Antitrypsin deficiency leads to development of emphysema. Remember, emphysema is the disorder of lung. So let's first understand about the lungs. Our lung tissue is the elastic tissue. This elastic tissue provides a stretchability of lungs. So this stretchability is required by the lung. What is the reason? See, when we inspire, at the time our lung needs to get expanded. It needs to be stretched. And when we expire, at that time our lung needs to get its original shape and size. That is called as a recoiling. So that important property is because of the elastic tissue. And this elastic tissue, they are elastic because of one very important protein. Its name is elastin. So because of elastin, our lung is a stretchable organ. The second important aspect about this elastin protein is that it is very important component of the structure of alveoli. Now this alveoli is the anatomical structure, very small anatomical structure. It looks like a very small balloons. So this is second alveoli, this is the third alveoli, and such bunch of alveoli, they are connected to this alveolar duct. Through this alveolar duct, air can enter inside this alveolar airspace, and when we expire, at that time air comes out of this alveolar duct. So for this formation of wall, or in the structure of these walls of the alveoli, this elastin protein is a main component. So this is the importance of elastin in our lung. Now we all understand that lung is very important organ, and it comes into the contact of atmospheric air all the times, right? And in the atmospheric air, there are so many different bacteria. So definitely, this bacteria, there is a continuous bombarding of this bacteria on the lung tissue. So how these bacteria are being handled by the lung? So when this bacteria enters inside the lung, at that time our body starts immunological response, and it leads to collection or recruitment of the inflammatory cells. Mainly these inflammatory cells are the neutrophils. So neutrophils accumulate at the places where bacteria are loaded. So there is an increased neutrophils in that local area. These neutrophils then later on secrete one very important enzyme, that is elastase. This enzyme is secreted. This elastase is from the family of the enzyme called as a proteases. So from the name itself, you can imagine or you can guess that this proteases, they are the enzymes which can break down another protein, right? So elastase is one of the member of that family. So by being a protease, this elastase can break down various proteins, including bacterial protein. So bacterial protein will be destroyed, and that will lead to killing of bacteria. And because of this mechanism, our lungs can be saved from the infection. But elastase is little bit non-specific enzyme, and so there are chances that this elastase can act on this elastin protein which is there in the lung, and it can break down, or you can say digest, the elastin, right? So if it is able to digest elastin, then our lung tissue will get damaged. But in a normal person, this elastase will not able to break down elastin. Why? The reason is that in our body there is a liver, and liver contains many hepatocytes. So suppose this is the hepatocyte. This hepatocyte synthesizes one very important glycoprotein which is called as α1-Antitrypsin. This α1-Antitrypsin synthesized by the liver hepatocytes, then it is transported through the blood and reaches to the lung. Now inside the lung, what it will do? It will bind with the elastase and inhibit the action of this elastase. And so this inhibition is at very sweet spot. Why? Because the inhibition by the α1-Antitrypsin will be such that elastase will be inhibited for breaking down of the elastin, but it will be not inhibited for the killing of bacteria. So that is the ultimate level physiological balance, and that is how our body tissue or our lung tissue cannot get damaged. So now coming to the question that α1-Antitrypsin deficiency. You can easily imagine that what will happen if this α1-Antitrypsin is deficient. So it will not able to act on elastase. So elastase activity will be uninhibited. So there will be a continuous breaking down of the elastin. And if this elastin is broken down, what will happen? Obviously, stretchability of the lung will be gone. So this leads to decrease or loss of stretchability. Stretchability of what? Stretchability of lungs. The second thing about the elastin is that it is very important component of the wall of alveoli. So what will happen? This wall will be broken down by the elastase, uninhibited elastase. So what will happen? Our alveoli will now start looking like this, right? Because its wall become weak and this interalveolar septa will be broken down. So instead of small air cavities like these, it will have now large air cavity, right? And in this large air cavity, what will happen? The surface area through which oxygen and carbon dioxide exchange, it is decreased if you compare it with over here. So there is a enlarged air spaces. And these two things, they lead to collection of clinical features that is called as a emphysema. So I think now you can understand that why in case of α1-Antitrypsin deficiency, there is a development of emphysema. Now there is something more to this story. See, α1-Antitrypsin is produced by the liver hepatocyte. Now α1-Antitrypsin is a glycoprotein. It is a glycoprotein. So it is a carbohydrate portion and protein portion. This protein portion is coded by a gene located on the chromosome number 14. There is a special location on this chromosome number 14 which is called as a PI locus. That is the name of location on the chromosome number 14. Now this PI locus contains a gene for the protein part of α1-Antitrypsin. Now normally this gene has several variation, and in case of normal person, there is particular M variety of gene is seen. This M variety is called as a M allele. This M allele gives rise to a normal α1-Antitrypsin. But there are certain mutant variation. These mutant variations may be S allele, then Z allele or null allele. This S allele has a decreased α1-Antitrypsin action. This Z allele has a very severe decrease in α1-Antitrypsin, and null allele has not at all α1-Antitrypsin action, right? So now what happens? These all different kinds of gene, they can give rise to a different α1-Antitrypsin which is not actually a normal α1-Antitrypsin. We call them collectively as a mutant α1-Antitrypsin. Now what will happen? This mutant α1-Antitrypsin will be synthesized by these liver hepatocytes, but they will not able to leave these hepatocytes. So what will happen? They will start accumulating or aggregating inside this hepatocyte. They will not able to enter into the blood and can go to its proper location, that is lung. They will start accumulating in the liver or hepatocytes only. So such large accumulation of α1-Antitrypsin, definitely a mutant α1-Antitrypsin, it leads to damage to these hepatocytes, and ultimately it can lead to hepatitis. And this hepatitis, that is a chronic inflammation, so it will lead to fibrosis and ultimately leading to the cirrhosis of liver. So the second clinical feature of α1-Antitrypsin deficiency is the hepatitis or cirrhosis of liver, or you can say liver damage. So remember that α1-Antitrypsin deficiency not only leads to emphysema, it can also leads to hepatitis and cirrhosis of liver. Now there is a third aspect also that I want to discuss, is that about the smoking. In case of the chronic smoker, what happens? That lung epithelium become weak, right? And because of that, more of the bacteria can reach to the lung. The second important aspect is that this smoking itself can lead to accumulation of neutrophil inside the lung tissue. So because of these two reasons, this smoking leads to more load of bacteria to the lung. This smoking leads to more of the neutrophils. So obviously elastase activity will be higher in the chronic smoker. And what will happen if elastase activity is higher? It will lead to damage to the elastin, and it ultimately leads to emphysema. There is third reason is also there for the smoking. See what happens, the smoking, it will lead to oxidation of α1 antitrypsin. In the structure of α1 antitrypsin, at particular 358th amino acid is normally a methionine. But by the smoking, this methionine is oxidized to oxidized methionine. This 358th location of the methionine is very important for the inhibition of the elastase. But once it gets oxidized, it will not able to act on elastase. So again it can lead to emphysema. So as you can see, this smoking has a threefold effect. One over bacteria, second over neutrophils, and third over the oxidation of methionine of the α1 antitrypsin. This all three pathway leads to increased elastase activity and ultimately leading to the emphysema. So that is the complete picture or pathophysiology of the emphysema. So now you know three main things. That is, one, α1 antitrypsin deficiency itself lead to emphysema. Second, it can also lead to liver disease. And third is that smoking can cause emphysema. So while discussing this one question, we had answered two more questions. So I hope that concept is clear. If you have any query or confusion, please write it down in the comment section below. Thank you.